Hello everyone, welcome to the another lecture of chemical bonding, class 11. Myself Suman Singh. So in the last class we have discussed about the ionic bond or electrovalent bond. So now today we will discuss about the covalent bond. So when we talk about the covalent bond, what is covalent bond? So covalent bond is a type of bond which is formed by the mutual sharing of electrons. Okay, as you can see here, the the bond is formed by the mutual sharing of electrons between the atom. Okay, and the atom participate in the bonding, contribute equal number of electrons for mutual sharing. Means covalent bond is what? Is a mutual sharing of electrons. Means suppose one electron is sharing, if we are talking about these two elements or these two atoms, this will, if they are sharing equal number of electrons, and with that, if they are forming a bond here, then it is called what? Covalent bond. Okay, so covalent bond is formed by the mutual sharing of electrons. Right now, covalent bond, it is basically three types. Okay, one is single covalent bond, double covalent bond, and triple covalent bond. Okay, so what is single covalent bond? So when we talk about the single covalent bond, single covalent bond are formed by the sharing of two electrons, means one electron each. Okay, here covalent bond is formed by the sharing of two electrons, when that is one electron each pair. Okay, as you see in the case of hydrogen, chlorine, and HCl, in both the three cases you will see that if you talk about the hydrogen and hydrogen, here one hydrogen is, here one hydrogen is, this hydrogen is donating one electron, and so is sharing one electron, and this hydrogen is sharing one electron, and they are forming a bond here, right? And in the case of chlorine, as you can see, seven electrons are there in, and seven electrons are there in the outermost shell of chlorine, as you can see here. So this one electron and this one electron, they two will share one electron, and they will make a bond which is called chlorine, Cl2, right? So if they are sharing two electrons, means if one electron each, then it is called single covalent bond, right? I hope you have understood this. Now next is double covalent bond. So when we talk about the double covalent bond, it is formed by the sharing of two electron pair between an atom. Okay, when the atoms are sharing two electron pair, that is four, total four electrons are shared, means they are forming a double bond, or we can say mm, double covalent bond. Okay, as you can see, double covalent bond are formed by the sharing of two electrons pair between the atoms, between two atoms. It is represented by double dash, as you can see here, between the atom. Now as you can see, for example, it is given here formation of O2. As we know that there are six electrons, right? As you can see here, six, both are having six and six. So what they will do, they will share two electrons each. Okay, so when they will share two electrons each, they will form O2, which will be double bond O, right? So this is the what called what? Double covalent bond. Okay, now next is triple covalent bond. So when we talk about the triple covalent bond, if the atoms are sharing three electrons each, then it is called triple covalent bond. As you can see, triple covalent bond are formed by the sharing of three electrons pair. Okay, and it is represented by a triple dash, as you can see here, between the two atoms. Okay, some of the example is given here. You can see the example of N2. So here N is what this nitrogen is, what it is doing, it is they are sharing three electrons each, and they are making a bond which is N2, and 2, which is a triple bond. Okay, triple bond between them. So I hope you have understood this, what is single, double, and triple covalent bond, right? Now one more thing is written here. Does the number of covalent bond formed by an atom depend on what? On what factor this number of covalent bond will depend? So it will depend on the number of unpaired electron in the valence shell. Okay, now next is the number of electron required to attain the inert gas configuration. Okay, on these two factors, they will, and this number of covalent bond will depend. Okay, first will be number of unpaired electron, how many unpaired electron does that atom has, and then the number of electron required to attain the gas configuration. Okay, now, so some of the example here, some of the example is given, as you can see. Beryllium, when you talk about BeCl2, here what it is doing, Be is just sharing two electrons with this, one electron with this chlorine, and one electron with this chlorine, and it is forming a, right, like this, BeCl2, right? In the same case, as you can see, BCl3, and here BF3 or BCl3, When we talk about share, boron has 3 electron, 1 2 and 3, right? So it will share this 3 electron either with the chlorine or with the fluorine. One electron, one electron to this chlorine, one electron to this chlorine, and one electron to this chlorine. Okay, in the same way, as you can see, for example of fluorine is given, one electron with this fluorine, one electron with this fluorine, and one electron with this fluorine. Okay, so in this way it is forming BeCl2 or BeCl3 and BCl3 or BF3. Okay, so here are some of the example. As you can see, it is also mentioned in your notes. Okay, now next is, based on the nature of atom, based on the nature of atom between the electron, covalent bond is divided into polar and non-polar covalent bond. Okay, based on the number of atoms between the electrons. Okay, based on the nature of atoms, what is the nature of the atoms between the electrons. Okay, based on the nature of atoms between the electron, this covalent bond is divided into polar and non-polar. Okay, non-polar and polar. So what is non-polar? Was first of all we will see, if non-polar is what, first of all we will see the definition. Here the bond is formed between the similar atom. Okay, shared pair of electron lies almost in the center, and electron cloud is uniformly distributed around the atom. Means what, non-polar covalent bond is generally formed by the same similar atoms. Okay, and since the similar atoms are forming a non-polar covalent bond, at that time whatever the electron they will share, that electron will lies in the middle. Okay, that will lies in the middle of the or we can say that that electrons will lies almost in the center. Okay, as you can see, the that atoms will lies almost in the center of the center, and the electron cloud will be uniformly distributed. As you can see the example of hydrogen, since you can see both are same, right? Hydrogen here also. So you can see the shared pair of electron is almost in the center. Okay, and the electron cloud will be uniformly distributed. In the same case, Cl2, you will see the shared electron will be almost in the center. Okay, almost in the center, and the uniform and the electron cloud will be uniformly distributed. So I hope you have understood what is non-polar covalent bond. It is generally formed by the similar atoms. Okay, next is polar covalent bond. So when we talk about the polar covalent bond, polar covalent is generally formed by two different type of elements. Okay, or two different type of atoms which has a difference in their electronegativity. Means if the here most of the time there is two different atoms. Okay, as you can see, non-polar covalent bond is formed between two dissimilar atoms. Okay, having different electronegativities. Okay, and the bond pair is displaced towards more electronegative atoms containing partial positive charge and charge on the less electronegative atom, and partial positive and negative charge on the more electronegative atoms. Okay, so what does it means what, if first of all it is formed between two dissimilar atoms. Okay, and next thing is what, there will be a difference in their electronegativity, since they are having a they are having a different, they are different elements. So what will happen, they will have different electronegativity, right? So there is an electronegativity difference between them, because they are formed by the two dissimilar element, two dissimilar atoms. So at that time what will happen, if this one is more electronegative, then what will happen, the electron cloud will shift towards this. Okay, and if suppose this one is more electronegative, then electron cloud will shift towards this. Okay, right, let me try again. So if this is A and this is B. Okay, so if A is more electronegative than B, so at that time what will happen, the electron cloud will shift towards the A. Okay, electron cloud will shift towards the A, and the shared pair of electron will not be in the center, it will be slightly shifted towards the A, right, this one. And when it will happen, at that time this A, the one which is more electronegative, it will carry a partial negative charge, and the one which is less electronegative will carry a partial positive charge. Okay, so I hope you have understood this. Once again let me repeat this. So it is what, it is a polar covalent bond is formed between the dissimilar atoms, okay, and having difference in their electronegativity. So at that time what will happen, the bond pair displaces towards more electronegative. As you can see, the bond pair displaces towards the more electronegative, or we can say that the electron cloud will shift towards more electronegative. And at that time what will happen, there will be a partial positive charge on the less electronegative element and partial negative charge on the more electronegative element, okay. As you can see this in the case of HCl. In case of HCl, as you can see, hydrogen is less electronegative than chlorine. So at that time what will happen, the electron cloud will shift towards the chlorine, and chlorine will take a partial negative charge since it is a more electronegative, and hydrogen will take partial positive charge because it is less electronegative, okay. Now in the same case, if you see in the case of HBr, in HBr, Br is more electronegative than hydrogen. At that time same thing will happen, this Br will take a partial negative charge as you can see here, and this hydrogen will take a partial positive charge, and this type of bond is called what, non-polar covalent bond. They are forming covalent bond, but there is a, since there is a difference between the electronegativity of this element, so what will happen at that time, the one which is more electronegative, they will attract the shared pair of electron towards themselves, and it will attain a partial negative charge as you can see here, okay. In the same case, when we talk about the H2O, here also oxygen is since more electronegative than this two hydrogen, so there will be a, this oxygen will carry a partial negative charge, and this hydrogen will carry partial positive charge. So I hope you have understood this, what is covalent bond, what is polar and non-polar covalent bond, right? Now next we will see the characteristics of covalent compound. So the first characteristic is they are made with distinct molecule, discrete molecule, okay, and strong bonding forces exist between the atoms of the covalent compound, okay. Now when we talk about the physical state, they are generally liquid and gases, or if it is solid then it will be very soft solid, okay. In case of sulfur and phosphorus or iodine, you have seen, right, in the lab, that is sulfur is very soft solid, right. So they are because they are covalent compound, okay, that is why. So covalent compound are mostly liquid or gas and soft solid, okay. And the various molecules are held together, whatever the molecules which is present in that covalent compound is held together by a van der Waals forces. I hope we have discussed about this, right, van der Waals forces in the previous chapter. Now next property is solubility. So they are generally soluble in non-polar solvent, okay, organic solvent like ethanol, ether, benzene, chloroform, etc., and they are insoluble in polar solvent, okay. So some of the covalent compound like alcohol, amine dissolve in water due to hydrogen bonding, right, because they are non-polar, they are a covalent compound but they are soluble in water because of the hydrogen bonding. Hydrogen bonding also we have discussed in the previous chapter, right. Now when we talk about the electrical conductivity, this covalent compound contains neither ions nor mobile electron, okay. So they are generally, they are unable to conduct electricity, okay, in either in the solid, liquid or gaseous state. Means what we can say, covalent compound will not conduct electricity, they are non-conductor, then they are insulator, or we can say, right, they will not conduct electricity because they do not have ions or mobile electrons in them, right. Now next is melting point and boiling point. So melting point and boiling point will be low, okay, low because in covalent compound molecules are held together by a weak van der Waals forces, that is why the melting point will be very low, okay. And some of the giant molecules just like diamond, SiC, silica, they have a very high melting point, okay. Exception, this is just an exception, that they are having a very high melting point. So we will, it is not a generally an exception, we will learn about this in detail in your solid state chapter, why their boiling point and melting point is very high for diamond and silica like this, right. Now next is nature of the reaction. So So when we talk about the nature of reaction, molecular reactions which are slow and complex, okay, and the covalent compounds show a structural and space isomer, okay, because the covalent bond is rigid and directional, okay, that is why they show what structural and space isomers, right? Now next is covalency. We will learn about the covalency. So covalency, always try to understand that it is defined as the number of electrons contributed by the atoms of the element for sharing with other atom, okay, to achieve a stable noble gas configuration. To achieve a noble gas configuration, how much element, how much electrons that a particular element has shared, okay, or a particular atom has shared, a particular atom of that element has shared, okay, that is the covalency, okay. So as you can see, covalency is what it is defined as a number of electrons, okay, how many number of electrons contributed by an atom is contributing of any element, of any element, okay, how much number of electrons is contributed by that atom of any element for sharing with other atom, okay, for sharing with other atom to achieve a noble gas configuration, okay. So that is the covalency. To achieve a noble gas configuration, if the amount of electrons shared by the atom of an element is called what covalency, okay. So if the outermost orbit has empty orbitals, okay, then covalent bond are formed in excited state, okay. So we will learn about this, what is excited state. We hope, I hope we have learned in atomic structure, ground state, excited state, right? So in the, if the outermost orbit has an empty orbital, then the covalent bond are formed in excited state, okay. So we will see this. Now variable valency in covalent bond, there are variable valencies in covalent bond, how it is. Now first is what, as you can see, variable valencies are shown by the, by those element which has an empty orbital in their outermost shell. If any atom has an empty orbital in his outermost shell, then they will show a variable valency, okay. How we will see this. Now next is lone pair of electrons. If lone pair of electrons get excited in the subshell of the same, to form a maximum number of unpaired electron, okay, and the maximum covalency is shown in the excited state. When there will be in the excited state, at that time they will show a maximum covalency, okay. Lone pair of electron if get excited in the subshell of the same, to form a maximum number of unpaired electrons, okay. We will see this how it is, how it will happen. Now maximum covalency is shown in the excited state. Always remember that the maximum covalency will be shown in the excited state. Now next is the energy. The energy required for the excitation of electron is called what, promotion energy, okay. The energy required for the excitation of electron is called what, promotion energy. So now we will see promotion rule. So what is promotion rule? As you can see, excitation of electron in the same orbit is called what, promotion rule. Suppose we see the phosphorus has an electronic configuration of this, as you can see, 3s2 and 3p3, okay. So this is what, this is the, here in that time the phosphorus has a covalency of 3, right, because in the outermost shell it has 3 electrons. Now what will happen when it will go in the excited state? What will happen, the one electron from s orbit, will jump to the 3d, okay, 3d orbit, okay. One electron from the s orbit, it will jump to this 3d. As you can see, it has jumped to the 3d. Now what is the covalency of this phosphorus has become, now in the excited state the covalency has become, you can see here, 5, 1 2 3 4 and 5, right? So as you can see here, I hope you are understanding this, right? Now next is sulfur. When we talk about the sulfur, its electronic configuration is 3s2 3p4, right? So what will happen when it will go in the excited state, the one electron will jump from here in the d orbit. As you can see here, one electron from 3p, it is jumping to the 3d, okay. So when it is jumping to the 3d, at that time what will be the covalency? It will be 4, right? 1 2 3 and 4. So since it is called what, 4, covalency will become 4 here, right? Now again one is second is second state excited state. So again after that, if it is going into a second excited state, at that time the electron from the s orbit will jump into the d orbit here like this. So at that time its covalency will again change to 6, as you can see here. So I hope you are understanding this. Okay, in the first excited state, what it will do, it will, the electron which was present in the 3p, it will jump to 3d. Okay, but in the second excited state, what will happen, the electron which was present in 3s, it will also jump to the 3d, right? So when it is jumping from 3p to 3d, at that time the covalency was 4, but when they were jumping from 3s to 3d, at that time the covalency has become 6, as you can see here, right? So you can see they have a variable covalency which is 2, 4 and 6, etc., right? So I hope you have understood up to this, right? So keep up to this. In the next class we will discuss about the coordinate bond. Till that, thank you.